Hi guys, in today's video we'll look at an example of combined techniques, an exam style question, and finally a summary. Hi guys, in today's video we'll look at an example of combined techniques, an exam style question, and finally a summary. This video will cover OCR specification point 4.2.4h.
So how do we use combined techniques to gather detail and information about the structures of our compound? Well, there are a wide variety of analytical techniques that you will have come across. These include elemental analysis, looking at processes such as volumetric analysis and percentage composition by mass spectrometry, and IR spectroscopy. Each form of analysis provides us with slightly different data and information about our compound. So let's take a look at an example so we can see what exactly we mean by this. So we've got an unknown compound and we're given the results of multiple different types of analysis. We're given the results of IR spectroscopy, percentage composition by mass, and volumetric analysis. So looking at the results of each of these different methods of analysis in turn, we can see what we can deduce about the structure of our unknown compound. If we begin by looking at our IR spectroscopy, we're told there are absorptions at 1,720 centimetres to the minus 1 and a broad absorption at 2,900 centimetres to the minus 1. We start by looking at the first peak. If we take a look at our tables of bonds, their wave number and the functional group that causes them. The peak at 1,720 centimetres to the minus 1 is likely to be caused by any of our carbonyl groups. We can see that value overlaps with all three of our ketones, carboxylic acids and aldehydes. So we can go ahead and write that in. The broad absorption at 2,900 centimetres to the minus 1 is likely due to our bond between the oxygen and the hydrogen atom in our carboxylic acid. This one over here. So again, we can go ahead and write that in. So far we know that our unknown compound contains a carbonyl group as well as a hydroxyl group found in our carboxylic acids. If we move on to have a look at our percentage composition by mass, we know that the compound contains 26.7% carbon, 2.22% hydrogen and 71.1% oxygen. We can use these values to determine the empirical formula of our compound. We write the elements at the top, that's carbon, hydrogen, oxygen, with 26.7% carbon, 2.22% hydrogen, and 71.1% oxygen. We know the relative atomic mass of carbon to be 12, that of hydrogen to be 1, and that of oxygen to be 16. Dividing through.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, just click the Snap Provide smiley face. Join me today and together let's make A-level chemistry a walk in the park.